Hi everyone, and welcome back to another video of IGCSE math preparation. My name is Irfan, and today the topic that I have selected for you guys is ratio and proportion. So without any further ado, let's start with what is proportionality basically. So there are two ways in which two quantities they can be related to each other. They can be either directly proportional or inversely proportional. So let's start with direct proportion. A good example of direct proportion would be your payment or the wage that you receive based on the number of, for example, specimens that you have to deliver. Imagine you're a worker in a pottery factory, and at the end of the day, the more pots that you make, the more money you will receive. So basically, you're getting paid based on the pots that you make. So there is a direct proportionality between the wage or the payment you receive and the pots that you make. So the less pots you make, the less wage you receive as well. So you see these two, they either go up together or they go down together. So that's direct proportionality. And let's do one ratio question regarding direct proportion. Imagine a worker in a garden can pick 100 apples from trees in 15 minutes, right? So if you ask him to work for 1 hour 45 minutes, right? So how many apples he can gather and put in the basket for you? So I think the question is quite clear. So this is where we can use the concept of ratio. However, these type of questions, they can be solved using two different approaches. The most common one, which all of you might have heard of it, is the ratio method. So basically, you have to form the ratio. So this is the equality. On the right-hand side, I have, okay, before you do anything, you have to convert the time and make everything, that the unit of the time should be the same. So here is minutes. However, here we have a problem. It's 1 hour 45 minutes. So if you convert it to minutes, that would give us 105 minutes, right? Because 1 hour is 60 minutes and we got 45 minutes already here. So in total, we got 105. And now what I'm gonna do on one side, so here is the X. Let's put the number of apples, which we don't know, that would be X. So what I'm gonna do, on one side, I put the X here on top, which is the number of apples to be picked. And in the denominator, I put the corresponding time, which is 105. On the other side, you should do the same thing. So it's not really difficult. No need to get yourself confused. Just make sure that in the numerator on the other side, you put the number of apples as well. So which is 100, and 100 apples is picked in 15 minutes, right? So the mistake that some students make is that they put it the other way around. They put 50 on top and 100 here, and of course they would get a wrong answer at the end. And having said that, you can easily cross multiply, right? And you can find X to be divided by 15. So that would be 367, I believe, right? And that would be 700 apples, right? As simple as that. So this is called ratio method. However, you could do another method, which is called unitary method. It is also common. It's not compulsory for you to learn both methods, because in the question, they wouldn't ask you, they wouldn't test your knowledge of the methods or the approach, the strategy that you want to use. So my suggestion to you is that if you're already comfortable with the ratio method, just stick to it. However, there is another way, and for the sake of completion, I have to also cover that topic. Actually, I rather to use the ratio method myself. However, unitary method is quite straightforward as well. Since we have 100 apples picked in 15 minutes, so we gonna find out how many apples is picked in 1 minute. And the answer is 100 divided by 15, right? If 100 apples is picked in 15 minutes, in 1 minute, you have to divide the amount of apples by 15, and that gives you the number of apples which is picked in 1 minute. And then you want to find out how many apples can be picked in 105 minutes. So you already found the answer for 1 minute. If you want to find for 105, you just multiply that by 105, and again the answer is 700 apples, right? So from now on, maybe I just stick to one method for the rest of the questions for this topic. And having said that, let's try some other type of questions. So, all right, this is a nice question. Let's see, let's say you want to participate in Carnival Day at school, and you decide to make some juice, and it is made of carrots as well as oranges. So that's what you need. And you get the recipe from your friend, and it says for every 7 oranges, you need 2 carrots. So this is the ratio, oranges to carrots, right, is 7:2. And at home, you already have 12 carrots, but you don't have any oranges, and you want to go and purchase some. You don't want to waste any money. You want to just buy the exact amount of orange that you need, right? So the question is how many oranges you need. Again, you can use ratio method or you can use unitary method. So I'm gonna do ratio method here. All I need to do is to form the fraction, but you have to be careful. Let me call the amount of oranges, let me label it to be X. So X is here, right? And for this much of orange, I need 12 carrots, right? And on the right hand side, so this is orange, this guy here is carrot, and the ratio of oranges to carrots is 7:2. So here again on top it should be orange, and here should be carrots. Okay, so if on the left hand side, guys, you have orange over carrot, you should follow and do the same thing on the right hand side. Okay, you cannot put carrots on top, so be very careful. And as long as you stick to this concept that the numerator should be representing the same quantity and the denominator is the second quantity, everything should be fine. Okay, everything goes smoothly. And then X is found to be, just multiply everything by 12 on both sides, and you will get 42 oranges, right? So that's another type of questions that you might see in the exam. And the next topic is how to divide a quantity. So we're not dealing with two quantities anymore, but how do we divide a quantity in a given ratio. For example, you want to divide a cake among you and your siblings. Perhaps, let's say you have a sibling, a younger sister or brother, and you want to divide this cake in such a way that you get a bigger portion, maybe 3 to 2. So this is you and this is your brother, perhaps. So meaning which you get, what does that really mean? It means you get 3 pieces, right? And your brother, he gets 2 pieces, 2 slices of cakes, right? And that means you need to divide the cake into 5 equal portions, right? 5 equal portions or slices, and then you take 3 of it, and the remaining 2 belongs to your brother. So that would be something like this. 2, okay, 3, and let me erase this one. All right, so I hope that's 5 equal portions. So your brothers get these 2 and you get the remaining 3. So you get the idea. If you get a question of this type, dividing a quantity in a given ratio, all you have to do is just to add up these 2 numbers, and then you continue from there. However, here we had just one cake, but let's say if you have a piece of wood which is 30 cm long, so the length is 30 cm, right? And you're asked to divide it into ratio of 1 to 4. Yeah, 1 to 4. So what would you do? You add up these 2 numbers, that is 5. So what you're gonna do with that, you come back here, you divide 30 by 5, and then one piece, right? One of those portions, it would be 30 over 5 times 1. The other one would be the same number, 30 over 5, but times 4, right? As simple as that. So the answers would be 6 cm and 24 cm respectively, right? So one piece is 6 cm, another one 24, and they should add up back to 30 cm, of course, right? Sometimes you will be given more than 2 numbers. Maybe they say in a company, the cars are produced in 4 different colors: red, blue, white, and green. Okay, so the ratio is given to you 7 to 5 to 3 to 1. So that's respectively. So it means 7 belongs to red right here, and the last one, this is green one, right? And then what you need to do, it's the same approach. You just have to add all of these. But let me, the question says there are total of 48,000 of cars produced, okay, following this instruction. They're asking you, okay, how many of these cars are white? Okay, white is this guy here, 3. Okay, so what you need to do, you add up all these numbers, that gives you 16, right? And then you divide 48,000 by 16, and then you multiply it by 3, because that would give us the number of white cars. In this case, it is actually 9,000 white cars, right? So it's not really difficult. And which brings us to the next topic. Now, this time we're going to talk about inverse proportionality, not direct. So a very good example of inverse proportion is a worker does a certain job in 3 hours, what would happen if you add another worker and ask, now you got 2 persons, right, doing the same task. So what would happen to the total number of hours? Definitely it would decrease, right? So increasing one quantity cause a decrease in the other one. So this is what we call inverse proportion, right? So it's not direct anymore. So the number of workers, if the number of workers increases, on the other hand, the job is done faster, meaning which the time is reduced, right? Same thing, let's say another example, you have a pool and you want to fill it with water, so you have only one tap, you open the tap and the job is done maybe in 4 hours. And the question asks you, what would happen if you add 2 more taps? So the number of taps increases, again, the time gets shorter, right? So I gave you some numerical value and it's time to solve it and see how it works. It's not really difficult, guys. Let's say there are 8 people which can pick the apples from the trees in 6 days. So the example would be 8 people picking, okay, apples in 6 days. So a job, it doesn't matter, it's picking apples, eating burgers, filling up a pool, you know, it doesn't matter what it is. So stop right there and multiply these two numbers, 8 and 6. That would give you basically 48, right? 48 days. Now, what is that 48? It means one person, for one person, it takes 48 days, right? This task. Now they're asking, let's continue reading the question. The question says, how many days it takes for 12 people to do the same job, okay? So for one person, it takes 48 days. For 12 person, of course, it's easy. You just divide 48 by 12, right? And the answer would be 4 days. And you can make a comparison with the statement given in the question. So we have increased the number of people, we have added 4 more people, and the number of days reduced by 2 days. But the most important part is here, right? This guy right here. Let me give you another example. Let's say the average speed of a cyclist is 27 kilometer per hour, right, for 4 hours. So that's the average speed of a cyclist, 27 kilometer per hour for 4 hours. And then at what average speed the cyclists need to cover the same distance in 3 hours. So same distance, now we reduce the time to 3 hours. Obviously, the speed must be increased, right? Because the time is reduced, so the speed must be increased. Now, what should we do? You multiply these two numbers, right? That give us 27 times 4, and then at the end you divide it by 3, which should give us 36 kilometer per hour. All right, and I think that's enough for the inverse proportion. Maybe we can move on to the last subtopic, which is actually the extended topic. So far, whatever I have mentioned is core. This last topic, which is an increase or decrease by a given ratio, it's very easy and straightforward. So let's say you have a photo and the size is 5. That's the width, and the height is, let's say, 8. All right, and you enlarge it by a ratio of 3 to 2. Okay, 3 to 2, which is basically 1.5 times bigger, right? 3 to 2 is 3 over 2, which is 1.5. Now, what would be the final result? Well, the final result would be bigger, of course. So the side which has the length of 5 cm, now you multiply it by 3 over 2. So the final result is 7.5 cm. So this guy right here is 7.5 cm. Now for the side with the length 8, we should do the same thing. You multiply 8 by 3 over 2, and the result is 12 cm. Now let's do it another way. Let's say the original and the final image is given to you, but the ratio is not given. So let's say we have a picture again, and you project it on the screen. So this side, let's say it's 5 cm. No, this is 5 cm, and the other one is 3 cm. And the width, which is 3 cm, on the screen, it is actually 0.9 meter. Okay, let's make it a little bit more interesting. I changed the unit to meter. Now they're asking you, first of all, what is the ratio of enlargement? Because obviously there is, this case is enlargement, right? 3 cm to 0.9 meter. And then they're asking for the other side. So first you have to find the ratio of enlargement. So, and remember, bear in mind that this is our image and this is the object. So if you want to find the ratio of enlargement, you should always put the image in the numerator. In this case, I have different units here, so I have to make the units the same. So I prefer to convert this guy to cm rather than converting this to meter. So because it's easier, just multiply this by 100, I get 90 cm. And the object in the denominator, that would be 3. And the final answer is 30. So basically, the ratio of enlargement is 30, meaning which this guy 5 cm, it has to be multiplied by 30 as well. It becomes 30 times bigger. So 5 times 30, that is 150 cm or 1.5 meter, right? Now, for increase, whether, guys, it's the case of increase or decrease, it doesn't matter. You just multiply whatever number is given to you by the ratio. Because if it's increase, you get a fraction like this, and A should be larger than B. And if it decrease, A is less than B. And you don't need to worry about this part. In the question, you will be given that. They say, for example, increase 70 in the ratio of 4 to 3. And as you can see, the ratio 4 over 3 is already greater than 1. 4 is bigger than 1. And all you need to do is just take 70 and multiply it by 4 over 3. You get the final answer. However, if it's decrease, like this question, they say decrease 60 in this given ratio 2 to 3. Can you see that 2 to 3, which is 2 over 3, this is already less than 1 because 2 is less than 3. So this is a decrease. And again, you just have to multiply it. So don't divide it just because it's a decrease. Okay, whether it's decrease or increase, you just multiply it by that given ratio. All right. Remember, it's not percentages. This is different. This is a ratio, and you just simply multiply. So having said that, let's do some past year paper question regarding this topic, and you would get to see how the questions looks like in the exam. So, all right, here we got some questions. Let's start with question number 1. We got a map, okay, is drawn to a scale 1 to 1 million. So what does that really mean? It means if you go 1 cm, if you move 1 cm on the map, right, in reality, you're moving 1 million cm. This is the map of the forest. The area is 4.6 centimeters square. Calculate the actual area and then leave your answer, give your answer in square kilometers. All right. So let's write that down. 4.6 cm square, right? However, this guy right here tells us that 1 cm is equivalent to 1 million cm in the forest, right? In the real forest. So I have to multiply this by 1 million. However, 1 cm is 1 million cm, right? But this is cm square. So that's where most of the students, they forget to raise this to the power of 2, right? So I repeat again, 1 cm on the map is equal to 1 million cm in the forest. However, this is a square, and you have to multiply it by 1 million square as well. So if you do that, the final answer that you get is 1 million is 10 to the power of 6, and that is 10 to the power of 12. 4.6 times 10 to the power of 12 cm square is how many kilometer square? So how do you, this is a matter of converting cm or cm square to kilometer square. So 1 cm is how many kilometer? 1 cm is how many kilometer? So if you want to change centi to kilo, right, you have to multiply by 10 to the power of -5, or you have to divide by 10 to the power of 5, right, guys? I hope this is a prefix. Maybe you can remember this from physics class. Centi is 10 to the power of -2, or 1/100, and kilo is 10 to the power of 3, which is 1000. So if you want to jump from 10 to the power of -2 all the way to 10 to the power of +3, so you have to, the index is 5, right? So, and yeah, 1 cm basically, the conclusion is that it's 1 times 10 to the power of -5 kilometers. So knowing this, let's get back here. So just substitute, instead of cm, you put 10 to the power of -5 squared, and the answer is 4.6 times the law of indices. This is -10 with +12, that would be 2, which is 460 kilometer square. So as simple as that. And there is another way, of course, guys. There is always more than one solution. In math, it's always like that, more than one solution to a question. So what you could have done is, all right, right from the beginning, can you see the ratio 1 to 1 million? So maybe a student says that means 1 cm on the map is equal to 10 kilometers. So you do the conversion here right from the beginning. Okay, so you say 1 cm on the map is 10 kilometer in the forest. So if you walk 1 cm on the map, so it means you walk 10 kilometers in the forest. Now, the area is 4.6 cm square. So basically, you have to, if you want to convert it to 10 kilometer, you multiply it by 10, but don't forget the square. So that's the square and kilometer square, and the result is also 460 kilometer square. So maybe some students, they do that, but still, in order to know 1 cm is how many kilometer, on the map is 1 million cm, but you need to do the conversion using this information that I have written here. Sorry, this one, the final result was this. This was just the explanation. So this is really important. I would say you should know this conversion, cm to kilometer. All right. So it's up to you which method you want to use. As long as you know the concept, it should be okay. Whether you do the calculation, do the conversion at the end, or you do the conversion first and stick to that all the way till the end. All right, let's move on to the next question. Again, it's a map. I strongly suggest you to pause the video and try to do this yourself. Again, this conversion at the end makes it a little bit difficult because we have centimeters here, then they want us to give the answer in kilometers, square kilometers, it's area. Now, what we can do, maybe this time I do the conversion here, 1 cm. So I say 1 cm on the map is equal to 0.5 kilometer on the field. Okay, so I hope you guys understood what I did here, because the scale is 50,000, it should get 50,000 larger, and knowing that if you want to convert from 1 cm to 1 kilometer, you need to divide by 100,000, 10 to the power of 5. Yeah, so that would be 100,000. So, okay, so if you do that here, you get 0.5. So 1 cm is not equal to half kilometer on this map, according to this ratio, okay, is half a kilometer. And then the area on the map is 1.2 square centimeters. So you take that and you multiply it by half kilometer, but don't forget to raise it to the power of 2, as simple as that. So at the end, you should get, this is 1/2, 1.5 times 1/4. So the answer is 0.3 kilometer square. Okay, so compared to the previous question, the scale is not that large. The previous question, it was 1 million. However, here is just 50,000, right? 50K. So I hope it was clear. If you didn't get that, maybe you can just pause the video and try to digest what really happened. But the strategy is quite straightforward. So what made it difficult, again, I repeat, it's actually this unit here, which made it quite difficult. So let's continue with next question. Question number 3, the volume of a child's model plane is 1200 cubic centimeter. The volume of the full-size plane is 4050 cubic meters. Okay, so we don't have kilometer here, hopefully, so you just need to know, guys, that 1 cm is equal to 0.01 meter, right? So 0.1 meter, all right? So this is the only thing that you need to know here, and the rest should be okay. Now, find the scale. Okay, they want us to find the scale. What we can do, as you can see, it carries 3 marks, guys. You cannot just simply divide this number by 1200. So that would be wrong to say 4050 divided, just like what we did for the enlargement of the image, remember, because that was in 1 dimension. Okay, it wasn't in 3 dimensions. This is the capacity, this is volume we're talking about. Okay, actually, now that I'm reading the question, it's 1 to n. Sorry, it's model 2. So I'm not gonna write it this way. So I write it the other way around. So 1200 to, so this is cubic cm. Let's write that down, to 4050 cubic meter. So it's up to you guys. Either you convert this to cubic meter or you convert this to cubic centimeter. I think it is easier for you to convert meter to centimeter. Let's forget about this, because simply if you want to convert meter to centimeter, so you just multiply it by 100, right? That's easier to do. So having this information here, I'm just gonna go ahead and multiply the right hand side by 100. So 100, but don't forget the index 3. So, and on the left hand side, we still have 1200 cubic centimeter. Everything cancels out except now, if I want to have 1 on the left hand side, I have to divide everything by 1200. So everything divided by 1200 from both sides. So if you divide this side by 1200, you get 1. And if I divide this side by 1200 as well, I get the answer n, which we were looking for, 0.375. And this is 10 to the power of 6. And this one divided by 1200 is 3.375 times 10 to the power of 6, which at the end you get, let me apply those zeros, and this is what you get, 10 to the power of 6. The decimal point was here. You have to move it 6 position forward. So this is the final answer. All right, let's move on to the next question. So this is a model of a ship. So maybe you can try to answer this question yourself. So this is surface area. So we have to be careful with the index 2, right? Calculate the surface area of the ship giving. So the model is given. Now we want to find out for the real shape. So in square meters, this means 1 cm, right, on the model is actually, on the model is equal to, so it's 200 times bigger. So 200 cm, which is 2 meter on the ship itself, on the real ship. Okay, so this is what you can do right from the beginning, or you can do the calculation, do the conversion at the end. It doesn't matter. Now, the model is this. So 7,000 for, this is the size. of the surface area. So instead of cm square, I replace it with 2 meter squared, right? So that gives us this index 2 belongs to these 2 as well as the m. So the unit would be meter squared. That's what they wanted, right? And then this is 4 times 7,500. That would be 30,000 meters square, right? That's the surface area of the sheep. Let's move on to the next question. Okay, so a car company sells a scale model 1/10 of the size of one of its cars. Complete the following table: scale model, real car. So of course we have to multiply this by 10. However, don't forget about the square as well as, I mean, the index 2 here, as well as the index 3 here. So you multiply this by 10 to the power of 2, which is basically times 100. So you get 13500. And this guy right here, you have to divide, but you divide by 1000. You divide by 10 raised to the power of 3, which is 1000. So basically 3 zeros is gone, and the final answer is 408. Having said that, I think it's a good place to stop here. Thank you for watching the video, guys. I hope you have enjoyed it, and I'll see you guys in the future videos. Stay safe and goodbye.